Herkese merhabalar. Reaxys çözümümüzle ilgili webinara hoş geldiniz. Bugün uzmanımız Piotr bizlerle. Sizlere sorularınıza daha profesyonel bir bakış açısıyla yanıt verebilmek ve Piotr'ın uzman perspektifinden Reaxys özelliklerini anlatabilmek için kendisinden destek istedik. Dolayısıyla İngilizce bir sunum olacak. Ancak Ümit Bey ve ben buradayız. Çeviri konusunda destek istediğinizde Q&A ya da chat kısımlarından yazabilirsiniz. Sohbet ve soru cevap kısmından sizlere destek olacağız. Ben daha fazla uzatmadan sözü Piotr'a vereceğim ama iki nokta var sizlerle paylaşmak istediğim. Sonbahar döneminde bir Reaksys kullanıcı günü düzenlemeyi planlıyoruz ve burada da Türkiye'deki ve Azerbaycan'daki kullanıcılardan örneklere ihtiyacımız var. Birbirimizin neler yaptığını paylaşalım ve örnek olalım diye. Dolayısıyla sizlerin de böyle proje ya da tez ve ya da diğer ders içerikleriniz kapsamında ya da başka şu an aklıma gelmeyen örneklerle Reaksys deneyiminizi anlatmak isterseniz bize ulaşmanızı rica ediyoruz. Zaten webinar sonunda bir ankette bunu evetse cevabınız ona tıklayarak bunu belirtebilirsiniz. Biz size ulaşacağız. İkinci konuda Reaksys Akademi. Reaksys Akademi şimdi linkini de zaten sohbet kısmından paylaşırım. Sertifikalı bir program. Temel Reaksys kullanımı, kimya ve öğretim amaçlı Reaksys'in nasıl diğerlerine, öğrencilerinize veya diğer çevrenizdeki kişilere öğretilebilir gibi üç güzel sertifikalı kendi hızınıza göre online yapabileceğiniz bir program var. Bunları da önemli tamamlamanızı rica ederiz, öneririz. Şimdiden güzel bir eğitim olmasını diliyorum. Piotr, the floor is yours. Thank you so much for being us today.
Okay, thank you for the invitation and welcome everyone. So maybe let's start sharing. Okay, I hope you can see my screen.
Yes, we can now.
Okay, good. So my name is Piotr Gołkiewicz, as I just said. I'm customer success consultant, subject matter expert in chemistry and life sciences. I am based in Poland. And I'm chemist by education, but not working as a chemist for a long time. Talking about Reaxys, I don't know if you actually mentioned Saide, but if there are any questions, please ask them during the session, and you
Okay.
can.
Yeah, I
Okay.
did, but let me just tell it
Okay.
again. Highlighting. Sorularınız olursa sunum sonuna beklemenize gerek yok. Chat veya Q&A kısmından, sohbet ve soru cevap kısmından yazabilirsiniz. O noktada zaten biz gerekli noktalarda Piotr'u uyarıp devreye girip hani cevaplamasını sağlayacağız. Şu an kayıt altına alındığı için herkes sessiz konuda webinar formatında ama tamamlandıkça ya da sizler sesli sormak istediğinizde belirtirseniz ayarları ona göre düzenleriz. Teşekkürler. Thanks, Peter.
Okay, thank you. So I'm really open to questions, and if you have some ideas of other maybe searches and so, I think you can use chat is the best option, and then I think Saide will monitor this, and then we can answer as we go. We don't need to wait for the end. So talking about Reaxys, many users remember Reaxys as a chemistry database, or even worse, organic database, organic chemistry database. Now it's AI-driven chemistry platform. This is what we are saying, and it covers all chemistry and chemistry-related sciences. So now I even call it life science platform because it contains also biochemistry and a link between biology and chemistry as well. So Reaxys supports every chemist. This is the first thing I want to say by accelerating chemistry workflow. So all the workflow from the idea, the design, and then making something, testing, analyzing, etc., and going in a loop and trying to do something. And this could be basically anything in the area of sciences related to chemistry. And Reaxys helps you with this thanks to comprehensive data. So amount of data, amount of both sources, articles and patents, but also extracted data is huge. So this is a huge repository of important data. And then great user experience so that it's easy and it's effective to use Reaxys. And it's also because we are using advanced technologies. At the moment, Reaxys contains 126 million documents and growing. And this is status from March, so it's almost 2 months, over 2 months old. I have to update it now because it's growing. And this is data which is coming from over 18,000 journals. Then we have patents, the most comprehensive coverage of patents, approaching 50 million patents, over 350 million commercially available and Reaxys-based compounds. Also reactions, 73 million unique reactions with experimental procedures, physicochemical properties, and also predictive retrosynthesis module powered by Ictos or by Penningai. We have 2 engines. And of course, it's world's largest curated database for bioactivity and toxicology data. So contains a lot of information and it is growing all the time. The second thing I want to tell you is how to search in Reaxys, because many people think the only way to search is to draw a structure in structure editor. And we see from statistics, the structure editor is roughly 85–90% of usage. So it's most of it, but we want to show you that there are other methods, and these methods are also very good, especially now with introduction of Reaxys AI. So you will see how easy it is to search with Reaxys AI and how much data it gives you, because you can ask question in plain English language. Keyword search is the type of a search that was always available, always there, and you could say either the name of a compound or a term or a physicochemical property, and then it was usually retrieving very precise information, so extracted information. Because when you use AI, then it gives you the answer, it gives you a lot of information. When you use keyword search, it gives you data mostly. Then it's, of course, a structure search, and yeah, most of chemists, especially organic chemists, use structure drawing, but there is also advanced way of searching, query builder that allows you to combine multiple data fields. And I will show you how to do this as well. And of course, we have a retrosynthesis module, both based on published, but also predicted information. If you think about the output, then it can be in many different ways, because it can be substances, it can be reactions, documents, including AI summary, commercial substances, or molecular targets, so biochemistry, bioactivity data. And of course, retrosynthesis, we will come to this. We have different, as I said, we have 2 engines, and we also have published data. So retrosynthesis is done based on the published data, but also on prediction. And coming back to AI, AI is now, of course, everywhere it's a big thing, and also in Reaxys, and it allows natural language querying. So you can ask the questions like a normal human, and then it provides a AI enhanced search, and then it gives you all the information based on high quality data. So this is very important. I see someone raise the hand, so maybe it's better if you just put the question in a chat.
İlhan Hocam, bir sorunuz var mıdır? Eğer varsa chat alanına aktarabilir misiniz? Ben Piotr'a aktarayım. In the meanwhile, Piotr, maybe you can continue when I receive the
I
question.
continue, and then yes. But in
Yes.
principle, I think you don't need to raise hand or something. You just put your question into the chat, and we will
Yes.
monitor it, and we answer on the spot.
Yes, I already delivered your
Good.
message. Yeah.
Thank you. Thank you so much. Thank you, Amit. So yeah, coming back to AI, I think it deserves a couple of words of description, because this is high quality database, because we see many AI engines, AI tools that give you information which is difficult to be checked. So you don't know the quality, you don't know the sources, it just gives you some responses, and then you don't even know if maybe it's not hallucinating, right? Because we know models based on LLM, large language models, they have a tendency to hallucinate because it's a nature of large language model, because it's not based on like a collecting of knowledge, but it's based on prediction of the next word. So, and then it simply finds some words that could be used somewhere, maybe in a different context. So that's why you have to be careful. Here it is, I would say 100% hallucination free, because it's based on very solid sources and controlled algorithms that just extract and summarize information, not create new information. Transparent searching, it gives you, I think, very transparent information, including the references. You will see that. User-friendly, it's, I think, as any AI, it's really easy. So what you do, you search in a quick search in search Reaxys field, and then follow up with the summary. And finally, high security standards. So you don't have to be afraid, because user prompts remain private. We don't use it for anything. We don't store it. We don't train our models with your prompts. Because it's built on responsible AI principles, like all AI tools built by Elsevier, we are always adhering to responsible AI principles, so that it's really yeah, safe and then well guarded. I've heard, I think, as much as I could understand Turkish, I've heard Saide talking about self-learning resources. Here maybe it's an additional summary if you want, but there are many different places where you can get help, and I think Saide will help you with this. So I don't need to do a lot of introductions here. So I think that's for the quick intro. And now I would like to go to online database. Sorry, I'm talking too much today. So let's start with the quick search. Okay, then later we will go to query builder, we go to retrosynthesis as well. So we have a lot to talk about, but let's start with a quick search. And in a quick search, you have two options. The search Reaxys, which historically was the algorithm keywords search, and now it's also the AI tool as well, and also structured drawing. First, we start with this. So historically, we were always teaching users that you can use keywords here. Maybe you can search for something, not even chemistry, but I don't know, heart attack, right? And you see, when I'm writing heart attack, it immediately goes and searches for concepts in a dictionary called Reaxys 3. And when I approve it, it puts it in a quotation mark, so it will search for a concept, not two separate words. I click on search, and I can search for biomedical concepts. You see as well, right? 550 biomedical based by the, 550 documents, and here are articles. And by the way, you see heart attack, but you also see myocardial infarction, which proves that when you map it to the dictionary, then it will search also for synonyms, which is very important. But in these days, you can search and you can also search, like, I don't know, UPAC name, and the more you type, the more ideas you are getting, right? And then it's enough that you select it. So searching for UPAC name is another way of searching. And in this case, you will notice we are not only getting documents, but we are also getting substances, right? Because we searched for a substance. And then you have to choose what you want, which view you want. And in this case, I clicked on substances. So I should have, where is it? Here. So here is my compound. Here is the substance record. I will come back to the substance record in a second. So you see, you can search like this. You can search by drug name as well, doesn't matter. So I can say diclofenac, and it's exactly the same. It's a search for a substance. So I will get substances, I will get documents, I'm getting substances, I'm getting documents, I also get commercial substances. So I can go to the commercial database where I can see, I mean, diclofenac is a drug, so maybe it's not the best example. Let's take coumarin, for example. Maybe that's simpler. And I'll show you. You have substances, you have documents, you have commercial substances where you can go and view commercial availability. So you can search immediately the commercial availability of a substance. It's here. And you see the commercial suppliers, product purity, packaging size, availability, etc. You see this is the link to the supplier. This is the link to the product, to the given substance, and we also have safety data sheet. So this is another way that you can use Reaxys. But normally what you would do is you would go to the substance view, right? Because you want to learn something about the substance. And when you go to the substance view, then of course, you get the substance record, structure, link back to commercial suppliers, link to retrosynthesis, but we will go there in a second, or you can go here. So this is retrosynthesis, and here are other possibilities. And here also all the information about the substance, identification, triglycinase, bioactivity, physical data, spectra, other data, preparations, reactions, and so on and so on. So all the data in one place, okay? But as I said, you can use keywords, and you can also say, be a little bit more complex, not too complex, not like for AI, but you can say, for example, solubility of, I don't know, vitamin D3, okay? So looking for solubility of vitamin D3, search. In this case, I'm searching for a substance and I'm searching for a property. So you see here the response is different, and you will notice this is very, very transparent, how Reaxys builds the query. So structure, you can click here, you can see the structure, that's vitamin D3, and properties solubility. If I go now to view results, I see the record of vitamin D3, and below I see heat data. Always search for heat data. Heat data is the answer to your question. And click on solubility, and you are getting solubility data on this compound. So very easy to find. And this is a typical keyword search. When you search for a substance, for a property, for a reaction, you can search for a named reaction, like Suzuki coupling, for example. You can search for mechanical properties as well, viscosity, maybe, I don't know, hardness. No, of corundum. So now I'm checking if Reaxys knows what corundum is. The corundum is, of course, aluminum oxide, right? Let's see if it will works. Maybe there are any results, because there might be no results for corundum, but let's see. So it should give me the record of aluminum oxide and then the information about this physicochemical property. Okay, there is a substances, great. Okay, so it's aluminum oxide indeed, and all the data, and then heat data, mechanical properties, and I am getting the values of Vickers hardness. So it doesn't have to be organic chemistry only. So that's why I'm showing you also examples from different areas. So you try different things, try bioactivity, inhibitors of COX-2, for example. So now we are getting to bioactivity area. We look for substances which are inhibiting specific pharmacological target. We can go to targets, look at targets as well, or we can go to substances. And I think this is for me more interesting. So there is 8.6 thousand substances that were somewhere in the literature reported as inhibitors of COX-2. And I can go into bioactivity heat data. Always look for heat data, right? And this is in vitro actually. And here I'm getting Okay, inductive agents, effect, protective agent, etc. Right? So, but this was not so clear. I just want to see if there is any. Yeah, like this. Inhibitor and target is COX-2, prostaglandin G8 synthase 2. So you get the data, and of course, always on the right side, you are getting the source. It can be a patent, it can be a journal, whatever, but always you get the source of information. And also for all these substances, I'm getting 8.6 thousand substances. You can also make by activity visualization and then go into analyzing data like substances here on the y-axis, and on the x-axis, you are getting the different pharmacological targets. You are getting the navigator, so you see where the most of the data sits. I also see this big circle here, so I see it's this column contains most of the data. Maybe you want to limit it, so you just click on the three dots. Three dots means there is more, there is like a menu below. If I click on it, okay, I need to move the navigator. Now it's like this, okay. Click, and for example, you can limit, exclude, or sort. So in this case, I want to limit to selected column, right? And now I can click here again and say sort by activity. So I will have the most active compounds on the top for my pharmacological target. I can also click on this orange or blue or area. But by the way, because these colors are coming from the color coding, and in the legend you see that high activity is marked with reds and yellows and the low is blue. So high activity is here, and I can click on a specific point, and this is showing me structure-activity relationship. So structure and activity towards a specific pharmacological target, and also all the information which is included. So everything is here. So very easy. So you see, I started from a very simple search, and now I'm getting into data analysis, really, because it brings you immediately in the middle of the data of information, etc. So this is the algorithm search. But I mentioned that we can also do AI search, and now it's possible from the same window. And by the way, I remind, if there are any questions, please stop me and ask questions, okay?
Piotr, I have a raised hand, but let me check if it is mistakenly or
Okay.
on purpose.
Yes, please.
İlhan Hocam, sorunuz var mıdır? O yüzden mi, yoksa yanlışlıkla mı el kaldırma oldu acaba?
Hayır, yanlışlıkla oldu, sorun yok.
Tamam hocam, teşekkür ediyoruz. Sağ olun.
Ama IC50'ler ile
Hı hı.
LC50 ile IC50'leri bir arada verebilir mi acaba? Nasıl bulabilir?
IC50'lerle
LC50, Lethal Concentration 50 ile
hı hı.
Inhibitory Concentration 50'leri
Hı hı.
bir arada verebilir mi?
Evet. I think you understand the question a little bit,
Yes.
Piotr. Our Professor Ilhan would like to see the LC50 and PLC50 together.
Yeah, it depends on the data, but here you see on the left, I opened the filters, and I can also do the same from the substance view. I can go to measurement to the parameters measured, and I can even open it like this in a new window, and I can then mark, because if you want IC50 and where is, we have LD, but little dose, but LC, I don't see LC. Okay, sort alphanumerical, and IC50 is one, and then L, next page. Okay, we don't have here LC. We have lethal dose, but not lethal concentration. I'm not sure if this was not lethal dose that we should look into account, because normally it's it's reported as LD. Here it's not here anyway. Protein. Decrease EC. ID 50 inhibition rate, etc. So these are the parameters we have, and they are reported as extracted from the literature. So we don't produce any new data. We don't produce any new parameters. So if certain parameter was measured, then it is reported here, right? And usually, as you can see by the number, IC50 is the most popular. If there is any other, then of course, we also include this. And also here, when we go to bioactivity visualization, we can also go to settings and we can change what you can look at each axis. So instead of targets, we can, for example, say parameter, right? So we can apply and we can see which parameters were measured and which are the most used parameters. Okay, level. And it's funny, there is no lethal dose here. It's just IC50, IC80, 90, ID50, etc. So you can look at the parameters and you can see those that are available simply. And I hope I answered the question. But you
It
can.
İlhan
doesn't
Hocam,
matter. IC50 and ID50. I mean, inhibitor
ID50,
dosage
yes.
of the same. Materials as a hazardous materials. Inhibitory dosage is equal to IC50 in vitro toxicity.
Yeah, it depends.
All tissues, okay?
Yeah.
IC, thank you very much.
Yes. Yeah, but depends on the substances we are, and I just search in this case for inhibitors of COX-2. But you could go for any substance and you can look at it, right? And maybe some, I don't know, some ideas of substances that are like really dangerous, and then you can go into bioactivity data and you can see both. And you can also, I think even you can search IC50. I'm just curious, IC50 of vanillin, for example. Curious if this can be found this way. Document substances, no. Because the substances are like this, and then I don't think there will be response to this question. No, there is no heat data. Okay, so but I will show you later in a query builder that we can search for a specific parameter. So we come to this. I remember this. Now the new thing that you can do here is the artificial intelligence, and then you can ask really wide questions. So for example, I have here a question. I will copy it so that it's quicker than to type. So for example, how has the development of polydopamine coatings enhanced the adhesion and biocompatibility of medical implants, for example? So it's a huge question, and before it was not possible to search for it, and now it's possible. So I'm just searching, and I will get the document view documents, right? And I go to view results, and then on the top of the results, because below I'm getting a standard document view, right? But here on the top is a summary. So click on view full summary, and here's the summary. Biocompatibility, etc. Then there is always a table that summarizes information. There is always a conclusion. And you will notice everywhere in the text are these small numbers, and these are the references. If I click on it, it will give me the reference. I need to close this window because I cannot then. Okay. So and then you get all the information. You can click on document details to move to the document view, etc., etc. So it's very easy. And also in the bottom, and this also is the same in a table. So click on reference and open the reference. So it's really trustworthy. It really gives you exact information. And also you can go to view all references. You can also copy this all report, this all summary, because the fact is that when you ask the artificial intelligence, even if you ask the same question, usually the reply may be different. It's not, I don't mean it's completely different, it says the opposite thing, but it will be constructed differently. Maybe now the summary is highlighting mechanism and effect, and in the other, if you ask it once again, it will highlight something else. So sometimes it's nice to copy it. You can copy the whole text and paste it to Word or whatever. So it's good. You can also give us your reaction. Is this good or is this bad? I had a question if it's possible to ask the question in a local language. At the moment, no. You can do this in other database of Elsevier Embase, but in this one is not. But there is one small trick. What you can do here, you can say, you can ask the question, and then you can say answer in Turkish. Okay, so I force it to answer in a different language than English, in Turkish. I don't know Turkish, so I don't know if I will be able to understand it, but I hope you will be able to understand it. No, come on. Okay, so looks like Turkish to me, okay?
Yes, definitely Turkish.
Okay, and yeah, nice. So you can do this trick, and then you just go down and you copy the whole thing, and you can paste it, and you can keep all these results, and then you have also the references. So it's really nice. It's a very nice tool, and it gives a lot of support and information. So this was keywords and AI. Then we have, of course, structure drawing. And as I said, many users are just drawing the structures. We have two structure editors, Marvin.js and ChemDraw.js. If you prefer ChemDraw, you can use ChemDraw. It's not a full version. It's like a JS, JavaScript, a simple version, but still it gives a lot of familiar looks. I prefer Marvin.js, so I am normally working in Marvin. We don't have time today to go through all the features, but maybe we should at least look at some of them. So first of all, before you start drawing, think if you have a nearest scaffolding, the nearest structure. Because what you can do is you can go to Insert Structure from Name, and I will use a drag. Why not? Diazepam. So if you have a nearest structure, it's much quicker to just enter structure from name, and then you can continue drawing. So then I can do as drawn. I can do the substructure search if I want to see all potential substitutions. I can do similar as well if I want to see similarities. I can be also specifically interested in special substitutions, like if I want to exchange this methyl group with any group, I could also go, for example, to Reaxys group generics, and here I have like alkyl, aryl type of group, cyclic groups, etc. I also have here on the bottom, I have a G. G is like R, like any group. So in this case, I'm saying as drawn, but this is actually a substructure, but only on this one atom, right? So if I transfer to query and click on search, I'm getting 567 substances with just one place which I allow for substitution. So diazepam is on the top, and then you see prazepam, pinazepam, halazepam, and so on. Looks like all of them are drugs because they have nice names. So quite easy, and the substitution can be on any atom, of course, like here. And if I just change it back to carbon, you can also use different bonds, of course, so I don't need to tell you. But this is including also coordination bond, which is good for like organometallic chemistry. Any bond, if you're not sure what type of bond you want to test all different bonds, stereo bonds as well. This one is also interesting position variation bond. If you want to test substitution on one of many atoms, right? So instead of testing this atom, this atom, this atom, this atom, you can say, mark this. I just took this bond, position variation bond, just marked like this. I have all these 5 atoms marked, and then there is a metal group by default, which is attached. I can change it to anything, like let's say any alkyl here, okay? So this means I'm looking for compounds that have any alkyl group on any of those 5 atoms, but just one, okay? So you can test positions here, and this is also a very nice option. And of course, you also have repeating groups. You have abbreviated groups here on the right, whatever. And you can attach it like this. You right click on it and you can expand, right click, contract, right? So that's quite easy. So sometimes these abbreviated groups are also very helpful. We also have, of course, periodic table, which is nothing new, but what is really useful sometimes is atom lists. So again, instead of testing single atoms on a position, you can just do atom list. It's highlighted. And then I say carbon, nitrogen, oxygen, or sulfur. And I don't know, for example, here. So with one search, I am doing 4 searches. Okay, so that gives me also a lot of freedom. Also, repeating groups. I can, for example, repeat atoms. So instead of, again, testing chains from 1 to 5, 1, 2, 3, 4, 5 carbons, I can use this repeating group option, mark this atom, and say exactly how many, or say the range. If I do 1 to 5, it means that I will test the chain from 1 to 5 carbons here. Okay, maybe let's do the heteroatom here. And we also have the possibility to do different size of a ring. So we can repeat atoms in a ring as well. So if I do, again, the repeating unit option, mark this one carbon here on the right side, and say, for example, 1 to 4, what does it mean? It means that when it's 1 and 2 will be 3, and when it's 4 and these 2 existing will be 6. So I am testing compounds having in this position starting from cyclopropane until cyclohexane, right? So in this case also with a nitrogen here, but I mean like 3 to 6 membered rings. And you can do this very easily. Drawing the reaction, of course, you can just do the reaction here as well. You can also bring the reagent or a catalyst above the arrow. Let's do, for example, no. Okay. Potassium carbonate, for example. No way. Like this, okay? So you can put the reagent or a catalyst above the arrow, but you cannot put the solvent like this, for example. I will show you the same example with a solvent later. And yeah, when you are ready, you just click on Move to Query and just run the search. So it's very, very simple, and you can use more generic types of searches to search for groups of compounds rather than one single compound. So you see here you have 5 atoms, here you have 6 atoms. There will be also 3 and 4, etc. So we will find these are 5 and 5, but like 4 here, right? So with one search, we've done all the group of compounds and all the group of reactions. So that's really very, very useful. I see there are no questions, but okay. Then let's go on. What else? from the useful options here, you also have smart groups. I don't know if you use smart groups, but this allows you to do different substitutions. Okay, maybe first let's draw our scaffolding like this, and no. Okay, I did it a little bit. I do it especially on the left because I need the right side, but maybe it was a little bit too much to the left. No. Let's move it. Okay. So like this here, I want the, oh, no, not here. Here I want the oxygen, and here I want also the different length of the chain. So I'm using repeating unit once again because I want to test different size of the chain. And now, how do you do the smart groups? I click on this smart group and start with, for example, this carbon and drag out. And I have R1, R2, R3, R4. You see, this is automatically numbered. I can click on any of those, stop auto numbering if I don't want it. I can also change the number of this smart group. So I will change it to 3. I want both of those groups to be from the same class. And then I draw these groups here on the left side. Let's do some of those, and maybe no. Okay. So this will be our R1. R2 might be any halogen, any this, and 3 could be any could be a hydrogen. It can be empty, but it can be also any alkyl. This is quite generic, or any aryl. Okay. So then I take again this tool that I was drawing the R's, and here is the same tool for R drawing, and then I just mark like this. You see, this is automatic. 2 and 3. So you need to put them in groups so that it's easy to mark, and then you see R1, R2, R3, and they are grouped. So I can have different groups of substituents. For more complex ones, I will need to also show the connection attachment, and this option is here on the left. Below the smart R group, there is the R group attachment. And I just need to mark those that are complex. I mean, these ones don't need this. And we are ready, I guess. So transfer to query. This is here, and search. So very easy, and with one search, you are getting a lot of information. And in the blue, you have your base structure marked. Okay. So different options, different types of structures. There is also many other ways you can search, but I think we have to stop here. Otherwise, we don't have time for the rest. Unless you have any specific question, then I think we move on, because I want to show you retrosynthesis, and then I want to show you query builder. So we stop here with the structure editor. I think you know it. By the way, you can also copy paste. If you have a desktop version, the standalone structure editor, just copy paste the structures, and you can use them here as well. So that's quite easy. Now let me move to retrosynthesis. Retrosynthesis, as I said, allows you to do the retrosynthesis based on the published, but also predicted. You can start it from retrosynthesis, or you can start it from any view. If I'm here in this view, for example, I promised to tell you about this. This is this synthesis plan and preparations. If I click on it, it tells me synthesize, find preparation, or create retrosynthesis plans. Find preparations will be just finding reactions. And I want to create a retrosynthesis plan. If I click on it, it moves me automatically to retrosynthesis, and then asks me for my settings for parameters, predicted or published. And I can edit both. here I can have like full roots, number of full roots of last step only, diversity of roots, processing time. If I don't get much information in the standard time, which is around 10 minutes, I can extend to 30 minutes. Also, if I don't get results on the full roots, then I can also change to last step only. Last step only means it's just splitting the big molecule into two, but also it does not have the requirement of beginning with starting materials that are commercially available. So it may give you two substances, two structures that are also not existing. They are also prophetic, but it gives you the idea, right? Because with this full root, it will try to go to commercially available starting materials. As I said, processing time again, select building blocks, libraries also, and published roots integration, meaning combination of predicted and published roots. And keep it on, because then it gives you nice combinations. Some part comes from a published part, and then maybe some only comes from a predicted part. So it's really nice. This is in pending AI. In another model, ICTOS that we have, you can also select or exclude intermediates. I'm not sure which one you use. So you can also go for intermediates as well. And here on the published side also, but there is less settings. Once you are ready, you just say create plans. And then it brings us to retrosynthesis module, and automatically it will start the process. Published will be ready in now. So it's very, very quick, because published is based on the published reactions, and predicted will now work for around 10 minutes, because this is what we said, standard working time. And this is a real time, the AI working in real time. Okay. If you give it more time, it will be more precise. It will do more thorough check. So if this doesn't work, then go back to extended time, for example, and then it will give you more results as well, because it will have more time to think, more time to go a little bit deeper and analyze things. So you can do something else in the meantime. When you come back after 10 minutes, the answer should be here. Like in these cases, you see, I have like, this one actually is 0, right? So because sometimes we also do retrosynthesis, predicted retrosynthesis for compounds that have known reactions, like this one have published. This has published reactions, but we still want to find some new ways of synthesizing. Then predicted is also created. In this case, this compound seems like there is 0 published, so there is no published synthesis of this compound, and we found 5 predicted. So if we go here, we are getting the predicted roots. Actually, this one is combined root, because predicted is a green color and published is blue, and this one is combined. So it contains, let's go to that review here. It contains both predicted and published part. And you also see the topography here, right? And you see the score. The score of 1 means it's 100% probability, but it's never 100%. So now in this case, the algorithm calculated that this reaction is 83% probability. So you have to go to the preview and then analyze examples for each step. Here on the top, you see the examples, like conditions. My screen is, wait, let me move it maybe to the right. Okay, maybe this will be easier. No, not so much. My screen is very small. But if you go to conditions, it doesn't want to open. Okay. No, the bottom view is even worse. Okay. So we do it like this. Okay. But then you go to conditions, and then you should see the conditions as well as here. Okay, you have conditions in tetrahydrofuran, water, etc. You see the original article, and wherever possible, you will also see the procedures extracted as well. I have a very small screen. I cannot make it bigger, unfortunately. But on the big screen, you will see all the data here. And these are Reaxys examples. So examples of Reaxys which have a similar mechanism of reaction. Okay. And when you are ready with your plan, you click on export. You can export basically anything, anytime. Click on export, select the format. Maybe I want to work with ELN or maybe Microsoft Word, and click on export. That's very easy. You can export up to 5,000 items 25 times per day. So make sure you have not more than 5,000 items on the list. So this is retrosynthesis, and here you see, for example, for this project, you see all your roots. You can move to the project, you can move to your synthetic project, or you can move to drawing here on the top. So I can move back easily to my synthetic projects, and let's see. Oh, this one is already finished. Great. 20th May, right? You see, Reaxys is remembering all my searches, but to use retrosynthesis, you have to be logged in. I didn't talk in the beginning about this, but in principle, we suggest, and I think this will be more and more requirement in the future, that you need to work with your login, personal login. It's very good because then you can save your data. You can set up email alerts, you can save searches. You will have your project saved in retrosynthesis. Your session will last longer. So there is many benefits why you should work as a registered user. And it's very simple to register. Just if you click on register, you just name an email address, very simple. And you can use the same login in all Elsevier databases, ScienceDirect, Scopus, SciVal, Embase, Reaxys, etc. So you can use the same one. If you already have a profile set up in maybe in ScienceDirect or Scopus, for example, then you can use it here. So you don't need to register again. Okay, so I think this was retrosynthesis. And by the way, I also mentioned a little bit of organizational stuff and logging. I want to move to Query Builder, because sometimes we have more precise question and we want to ask very precise question. Then we want to use fields. And here you see the fields are on the right side. And mostly I don't use the other ones. PubChem, Reaxys contains PubChem, but I usually use Reaxys fields. And those fields are related to topics and keywords, identification, physical properties, which is physicochemical properties, spectra, target by activity, other reaction by bibliography. So many different types of fields that you can use, right? So you can, for example, use identification. Let's click here, for example, chemical name, right? And when you click on the name, you see chemical name. You can be specific again. You can give, like I was doing, the UPAC name. You can do the part of the name as well, like triamine or something. And you want to test maybe all triamines, then you can change is to contains as well to only find compounds that contain it. So you can play with the name here. This can be also a UPAC name, can be also like a natural name, pyridine, for example, like this. So it doesn't matter, right? So you can search. You can also search for example, physical properties, melting point, for example, boiling point, etc. So, and you will notice someone raised the hand. Can you please ask the question in a chat, please? Or if you can unmute your phone, maybe you can ask the question also.
Ali Osman Bey, I think we have a raised hand, so let me allow to talk. Ali Osman Hocam, buyurun soru sormak isterseniz. Yanlışlıkla da olabilir tabii. Sanıyorum yanlışlıkla olmuş. Piotr, I think it's mistakenly raised hand,
No,
so
okay.
yeah, we can go on.
Okay.
Okay.
Good. So let's try the query builder. And you will notice I just click here on any two fields, which doesn't make sense, but just to show you, if you enter more than one field, and you can also do 3 fields, they're automatically connected with the logical Boolean operator and. If you click on the end, you can change it to or, and, not, near, next, proximity. So it gives you very wide possibilities of creating your query. Okay. By the way, talking about parameter, it will be somewhere in top targeted by activity, most probably. But there is also one more idea. You don't need to search for a field, like scroll through all the fields. You can search for a field. So there was a question about parameter. So you see, I just start typing 5 letters, 4 letters is enough. Measurement parameter, and I can, for example, go and see in the lookup list. And there are, for example, different types of parameters. It doesn't have to be biochemistry, it can be, but I can say LD50. I'm curious. Okay, LD50 is here. Measurement parameters, chemical parameters, analytical parameters, those LD. Okay, let all those make sense. So in this way, I can use just one field, and I can say, I want to see all the compounds that have let all those number measured and available in the literature. So here I have to decide what I'm searching for on the bottom: reactions, targets, substances, documents. In this case, I want to search for substances. So there are almost 53,000 substances, 52.9, you see, that have LD. And by activity heat data. Okay, so it's toxicity, safety, pharmacology, and you see LD50 measured, and the value of LD50 as well, unit milligrams per kilogram, and biological species as well. So if I wanted now to say, I want only to see LD50 for special structures, and I'm just looking, okay, I'm looking for flavones, okay? So I say I want to find all the compounds that have a flavone structure in it and have LD data, LD number. So here I can also use the structure as a field. If I click on a structure, it's edit. So structure can also be a field, right? So I click here and I will do the flavone substructure, just very generic. So this is just an example. So what I will do the substructure search. I'm not going to do a specific one. So it's just a very generic example, just to see how the query builder works. And so I'm doing the substructure search, transfer to query. So I'm saying I want to see all the compounds that have this substructure and have any measurement parameter like this, right? And I can change the operator, contains, ends with, etc. In this case, maybe is okay. So let's see. So you remember we had almost 53,000 substances. Now we have 401 substances, and all of them will have the flavone structure. All of them, you see, all of them. And all of them will have by activity heat data. And I see it's in vitro and toxicity. I wonder, LD in vitro? Okay, LD yes, LD value 67, for example. And toxicity, pharmacology, also the value as well. So this one is a microgram per milliliter. It's different. This is in milligram per kilogram. Okay. So now let's assume I want to do only I need only the data which was measured on rats. So I would need to find again, close it. So I can go like this. I can search as well. but you see, I can crystal. So you see, searching like this doesn't make sense, but I forgot where to find it. Let me do once again. It will be species, no? I think it should be species. Let's see. No, not this one. Toxicity. Biological. Biological. Oh, B. Okay. I was looking for S, and this is, of course, biological species. So I should look for a field called biological species. Of course, it's here. So I'm adding this third one, and I'm saying I want the study based on rat, and maybe I can use the semicolon and say mouse as well. Only. Okay, so now I'm limiting again the number of data because I just want this from 401 we had, and now we have 326. Okay. And when you go into by activity hit data, you will notice that it's only mouse or rat, right? So biological species, it's mouse or rat. So it's the tool that you can ask the question and you can be more and more specific. I wonder if there is a possibility to look for a value of the parameter, because now here we can only select the parameter, but we should be also able to say the measurement px. Okay, because we can only do the px measure, but not the parameter value. We can also do cell lines, for example, if you want, organs, tissues. So you can add any fields you want, and you can be as specific as you want. But maybe I start from quite a complex example. Let's start from more simple example. There is also, before I do this, there is also quite a lot of information, useful information in other group. Other, nobody goes there because nobody knows what other is, but other is very useful because here we have two or three important type of information. One is the environmental. There is a lot of environmental information. Exposure assessment, concentration in environment, bioaccumulation, biodegradation, abiotic degradation, stability in soil, oxygen demand. So there is a lot of things. Then there are two very important fields. One is use of the substance, how the substance is used. And often when we work on a compound, we want to work on a specific compound for specific use. So I can add this field, I can show fields, and I can put, for example, I'm working on a pesticide. Right? And I could go like this. So I want all compounds that are reported as a pesticide, but I want a specific structure because I'm working on phenylpirazole compounds that I want to be a pesticide. So here I will add a structure again to this as a second part of my question, and I will do phenylpirazole type of a group, like this. And double bonds. Okay, that will be my structure. I just do again substructure, very simple. Transfer to query. So I want compounds that have phenylpirazole part in it and are pesticides. I will do not is, but starts with, because pesticide or pesticides depends. So I therefore allow suffixes. So I search for substances again. So you see, you can translate your thinking into a query. And here is, for example, fipronil that has this phenylpirazole part. And below hit data, use pesticide. And here you have patents. So very easy way to find information. Oh, I should go here. The second very, very important field in other is this one. Actually, first one on the list, isolated from a natural source. And I know in Turkey, researchers work a lot on natural compounds from natural products, from fruit, from flowers, trees, minerals, anything that comes from nature. So it will be also extracted and available here. So, okay, let's do this. Isolated from a natural source. Show fields. So let's do, for example, garlic. Okay, garlic, very popular thing and very healthy. So there is a lot of compounds in garlic. We want to see what are the compounds that researchers reported as isolated from garlic. Let's go for substance. Again, substances. We mostly use substances, but we could also use reactions. And there will be 157 compounds, like quercetol, like this one. And when you scroll through the list, you will notice that, maybe not here, oh, like this one. I'm interested in sulfides, and this one is disulfide, right? So it contains this sulfur-sulfur bond, and I want to find these compounds within this 157 group. Instead of scrolling, I want to find them. How can I do this? Go back to Query Builder. The first part of my question was already asked. So what are the compounds isolated from garlic? And the second part will be that it has to contain a specific bond. So I will use the structure again. Structure, draw structure. And what do I draw? What I want to find. I want to find sulfur-sulfur bond. And then I do again a substructure because I don't know what is around. I don't care. Anything that comes around. I just need the sulfur-sulfur, at least one. By the way, this is at least one. It can be more. Let's see. So if I click on add to query, so I'm saying compounds isolated from garlic that have at least one sulfur-sulfur bond, substances. So we are down to 47 substances. And the allyl disulfide is here. But you will notice I already have 3 sulfide and most probably also this is 3 sulfide, but there is also tetrasulfide, like this one, 4 sulfurs, right? But I don't want them. How to get rid of those? I just want 2 sulfurs. That's it. Okay, let's go back to Query Builder. Now it will be a little bit more complex, but I want to show you the power of this tool. So I want this group of results that have sulfur-sulfur bridge, and I want to deduct that have 3 sulfurs or more. So how do I do this? I have to draw it. So I use the structure again. You can use the same field many times. So I use the same field. I will draw what I don't want. What I don't want, 3 sulfurs or more. So it's enough to draw 3 sulfurs. So 1, 2, 3. And they must be connected, of course. And I do the substructure. So this means all the compounds containing 3 sulfurs connected or more than 3. Transfer to query. And now I said this is what I need to deduct. What is the logical operator for deduct? It's not, right? So I say not. Now what I need to do is I need to group those so that it's like parentheses in mathematics. How do you group fields? Very easily. You just have here this drag option, these small squares. Take it and drag over this field. And I created a group. You see, this is a group 1. You can even click here. You can even rename it. So not is here. So I'm saying this minus this and garlic. Okay, let's see. You get it? It's really simple. It's a graphical. And here we are. 2 sulfurs, 2 sulfurs, 2 sulfurs, 2 sulfurs. This can be in a ring as well. I mean, 2 sulfurs. So no 4, no 3, just 2. Okay. There could be another sulfur or 2 sulfurs, but in a different place, but not bind together, right? Not in a one binding, not in a one bridge. That's also very important. So you see, I can create these searches very easily. I can create these forms and I can then use them. It doesn't have to be organic chemistry, by the way. It can be also molecular formula. If you are in organic chemistry or stoichiometric chemistry, then molecular formula is much better. For example, I want to find, for example, palladium. What was it? Palladium. Now I lost it. Palladium compounds that are arene and palladium compounds used in stereoselective catalysis. Okay, what if you are in catalysis, you want to find it? So arene and palladium. Yes. How to do this? Here you just use the element symbols, right? So arene, you could say number of atoms, but here we don't know. We want any number of atoms. So instead of a number, we put a question mark. Question mark means any number of atoms. Palladium, the same, any number of atoms. And anything else, which is the asterisk. So in a text search, question mark replaces one letter or no letter. Asterisk replaces any number of letters. Here, question mark says what number of atoms is of a selected element, and asterisk means any other atom, so like a substructure. So this is the first part of our question, arene and palladium in any number and anything else. So this will be, oops, sorry, I clicked unnecessarily, sorry. Once again, arene, palladium, and anything else. Okay. So this is all compounds containing arene and palladium. And the second part of my question is the question about catalysis. So let's see if we can search a field. Catalyst investigation. If you wanted reagent or catalyst for your reaction, use this one. But here is catalyst investigation, show fields. And this will be most probably here in specification of catalysis. Yes, stereoselective catalysis transfer. So you see now I have like stoichiometry, but very generic, and also I want stereoselective catalysis as a type of reaction that these compounds are used in. And I'm getting compounds. Catalyst investigation is below, and stereoselective catalysis is here. So it's really very, very, very easy to find. Just think of combination of different fields, what you want. You can search also for alloys here. I will get rid of this one. How about arene and nickel alloy? Why not? It can be also an alloy. So it doesn't have to be organic chemistry. It can be an alloy. Nickel arene permalloy, for example, avaroite, invar. No problem. Inorganic compounds, the same. Great place for asking for inorganic compounds here as well. Biochemistry. Target, for example, pharmacological target. And we want to find, maybe let's use the structure as well. And here is the structure. This was the example, like, okay, benzimidazole-based goods. So again, I'm using very generic examples, but you can use yours more exact. I don't want to use time. So substructure, and that's it. Transfer to queries. I'm using quick examples to show you how it works. And I'm looking for compounds that are tested against cancer, so that have a special effect. Searching for effect, substance effect. And I will say cancer. And contains is by default here, which is good, because I want cancer, anti-cancer, cancerogenic, cancer therapy, cancer inhibitor, growth, whatever, right? And I want the specific target or targets. Target is enough. Okay, target name. So I'm adding target name, and I will use, for example, EGFR, maybe also semicolon, HER2, for example, and maybe, I don't know what else. Maybe this is enough. Let's see. Oh my God, 1,140 compounds. Okay, and by activity heat data, safety pharmacology. So you see antineoplastic. So I said cancer, but it understands cancer or anti-cancer is antineoplastic. And then it also tells me inhibitor, etc. value. It also gives me the cell line. So if I wanted to do the cell line, I'll just copy it for a quicker. I can also say I want only the research. No. This is slow. Cell line, right? I can also add cell line at the end. I will paste what I just copied, okay? So not starts with, but contains, because these names are normally, might be longer, again, substances. So you get all these possibilities, and okay, this is just this one substance that I have seen that was tested against this cell line, it appears. But indeed, this is all here. So this is how you can search it. The same way you search for reactions, and yeah, and it's basically the same. I think I've covered most of it. I could talk for another hour, but maybe we should take some questions. What do you think? Or shall I continue?
I'm just checking the questions, but there's no question.
Maybe you
Let
can
me
ask.
ask again. Eğer sorunuz varsa canlı bir eğitim. Dolayısıyla şu anda sizler de vakit ayırdınız. Özellikle kendiniz şu zaman şu eğitimden sonra denerim dediğiniz bir şeyler varsa bile paylaşırsanız, hani uzmanımızı da hazır burada bulmuşken, evet, ondan yani o ilgili örnekleri vermesini isteyebiliriz. Yani normal chat ya da Q&A kısmından da yazabilirsiniz.
Or which area of chemistry maybe we should go for last example?
Evet, yani
Maybe
son
that's better.
örneğimizi de, yani illa bir spesifik şey değil, bir inorganik, organik, yani bir kimya alanında ya da ilaç keşfi, farmakoloji olabilir. Yani nasıl istiyorsanız, hani hangi alanda çalışıyorsunuz onu da yazabilirsiniz. O alanla ilgili bir örnek yazarız. Örnek yaparız. Son örneği en azından sizlerin canlı olarak katıldığınız, vakit ayırdınız, sizin eşinize yarayacak bir örnek yapmak isteriz. O yüzden hani sorunuz yoksa bile alanınızı yazarsanız biz onun üzerinden uzmanımız bir örnek gerçekleştirecek. Yeah, we received feedback. Thank you, Ali Osman Bey, Ali Osman Hocam. It would be great to have an inorganic example, he wrote.
The thermochemistry,
And yes,
what is this?
thermochemistry data.
Thermochemistry. Wow, okay.
Interesting, right?
Yeah, good.
Sağ olun, çok teşekkürler Ali Osman Hocam.
What is it? Which? My computer is slowing down like crazy. Okay, so we have other thermochemical data. Let's see what's available. Okay. So we have entropy, Gibbs free energy, heat capacity, thermodynamic properties, entropy, of course. Heat of combustion at constant volume, thermodynamic properties as well. Not bad. So you see, you can also, where it was mentioned in the article, you could also go for like enthalpy, entropy, thermodynamic, Gibbs energy, Gibbs free energy. So you could go like this and try to, there is more questions. Yes, these are thermodynamic data, great. Yeah, so basically what you could do, you see, I want to find an entropy, maybe, transfer, entropy, and then I want to find it for a specific structure. I can add a structure to it, or maybe for a group of compounds, that have a certain number of atoms or something. Yes, sure. Yes, you can please, Ali, Professor Ali, please write, give me your questions. This will be great. So I can, for example, use molecular formula as well, right? I can combine it with some other information. I can just go and search for substances for which there is entropy data. Oh, we have an echo. Antioxidants, okay. Great. So why don't we say we search for compounds that have entropy, and at the same time, in target and by activity, a substance effect, let's do antioxidative. So after A, there will be N on T. So I will say contains, actually starts with is enough, right? Because we just need the ending of the word. So let's see if there are compounds that have both. Okay, 354 compounds have both, because we haven't yet water. Okay, let's see benzaldehyde, for example. So entropy, okay, we don't have a number, but we see the source. And then in bioactivity heat data, we see here antioxidant, right? So you can do this. We could try to see, because when we think about antioxidants, they're usually like flavonoids, for example. Why don't we use the structure on top of it, and we look for a flavon, and then we do the substructure. So we look for flavonoids. So I have, I'm trying now to, this might be too many questions, but I'm trying to see what are the flavonoids that have antioxidant or antioxidative activity and have entropy data. One, not much. Okay, so for this one, we have entropy, tetrahedron letters, okay. And bioactivity heat data here. So we see it's antioxidants. Okay. And of course the structure contains, so it might be too much, right? If I would take out the thermochemical data, I just delete this field, so I will leave only the flavonoids, and I want to see those that have antioxidant data. This will give me most probably many more. Oh my God, 6,000 compounds. Like quercetal, for example, and oh my God, here I see in vitro, in vivo, toxicity data. Great, so a lot of data. And antioxidants. Okay, a lot of data. So you see just the structure and antioxidant is, so substance effect, basically. Substance effect, you can do anything. You can do antioxidant, you can say anti-Alzheimer, you can say anti-proliferative, whatever, right? I mean, it's like whatever you want the effect of the substance to be. So you can use this, and this is quite easy. Sometimes you can use the use as well, because the field of use, it is antioxidant as understood as use of the substance. And so sometimes it makes sense also to test the other fields. Or there is also, we delete the substance effect, we leave the flavonoids, because there is also these ones, topics and keywords on the top. There are only 4 fields, but they're really useful, because this one is like, if you are not sure which fields to use, there's a lot of information in the substance properties and comments, and in reaction information, reaction data and conditions. So here, substance properties and comments, I'm adding, and I'm saying antioxidative. So I'll say starts with, okay? And let's see if I get more substances. Okay, 957. But this will be most probably, yeah, that's a use, you see? So this information can be in the field called substance effect. So you have to be aware of this because this is an effect. Or mostly in patents, it will be in a field called use because from the patent point of view, this is like their, how do you use them? Okay, so it can be also here. Or you can use the field called use simply. But sometimes it's better to use this more generic field as well. So it takes a little time to get used to this and to find the fields. To find the fields, please remember you can find them. And yeah, experiment. This gives you a lot of possibilities. Remember at any option you can save stuff, you can export results. Here you can also save your form. So when you create something very complex, you can save it, you can give it a name. When you save it, then when you go to forms, here next to fields, there are forms. And there are my forms. And this is all you save is here. So here, for example, are anti-inflammatory compounds, compounds against COVID, and target name is P58 MAPK, for example. So depends what you want to do. Azoles with fungicidal activity, carbon nanotubes, etc. So I created like many different forms, and you can quickly find them here, and you can use them. Mechanism of reaction as well, etc. So different forms. Okay, I think I stop here because I have a next meeting in 3 minutes as well, but maybe there is one more last question.
I think, yeah, there is no question, and Ali Osman Hocam is thanking for your reply. We have some requests for food science. I think it is also related to antioxidants, so I think it is replied as well. Yes, thank you, Piotr. It was a really long and effortful session, as always. And we are happy to have you as Turkish and Azerbaijan Reaxys users. And I will let you know if any follow-up questions received from our participants.
Please, I would like questions to be more like trying to adapt to your needs.
Yes,
There
and
were
we
not too many.
encourage our users to just reach to us, share their examples, share their challenges, so that we can design our trainings accordingly more interactive. Because mutually we're allocating time, so it's get the best out of it to share your experiences.
Yep.
Yeah.
Thank you. Excellent. Everything excellent.
Thank you
Thank you
İlhan
so much.
Hocam. İlhan Hocam çok sağ olun. İyi ki geldiniz. Katkılarınız için de teşekkürler. Çok sağ olun. Görüşmek üzere. Herkese iyi günler diliyoruz. Kayıt paylaşılacak herkesle. Çok sağ olun.
Thank you.
Thank you, Peter. Thank you so much.
Thank
Bye.
you. Bye-bye.